Wonderful. So let's continue our journey. So we are now at session 8. So just like yesterday, we want to highlight a few initiatives from the ecosystem. So I'm excited to welcome to the stage 4 panelists that will be presenting 3 projects. So Christine Loisel-Lapointe, Emily Taylor-King, Madeleine McPherson, please join me on the stage. And Jessica Webster, who was supposed to be here today, will be doing his presentation remotely. For some reasons. So basically, we'll have her also on the screen later. So at this stage, we'll start by a first project from the Canadian Centre for Energy Information. They have a booth there. I'm sure you've visited already. So they are a key partner of the EMH. So we have with us Christine Loisel-Lapointe, senior researcher with the Centre for Energy and Transportation Statistics at Statistics Canada. She brings decades of experience to her roles. Alongside her, we have Emily Taylor-King, who served as a senior analyst at the Canadian Centre for Energy Information, focusing on web and data integration. So I'll be back to introduce Jessica and Madeleine after that, but Christine and Emily, the floor is yours.
Thank you so much for that, Edward. And thank you very much to the EMH for inviting us here and allowing us to showcase a few of our new products and tools that we've been developed in the past year. So just a few things that we wanted to talk about today. So we have developed recently a high-frequency electricity data dashboard, along with a .stat data explorer, and we also have some new content that we've added to the Canadian Centre of Energy Information website. So what is the Canadian Centre for Energy Information? Well, it's a one-stop shop that brings energy information together from across Canada. So the goal is to work with federal, provincial, and territorial partners to reconcile and integrate energy data from a broad number of Canadian data sources, and to make the data from multiple providers available in one central and user-friendly location. So through this collaboration, the CCI is working on to harmonize definitions, reconcile and integrate energy data from a broad number of sources, improve coherence, timeliness, and also to provide access to new data projects and visualizations, tools, and analysis to Canadians. So first, I wanted to discuss the HFED initiative, so the High Frequency Electricity Data. So this is a CCI project in collaboration with Natural Resources Canada and the Canadian Energy Regulator. High-frequency data is collected by province and made accessible in a central location through a dashboard. So what do we mean by high frequency? So this is data that's being collected every 5 minutes, every 15 minutes, every hour, depending on the data source. So indicators of interest for this project include system load, generation by type, transfers of electricity between province and with US, and for certain provinces, price data. So why do we want to do this? Well, electricity data is often published monthly, and it's often published 3 months behind, which doesn't really capture the dynamic nature of the electricity market. As well, as you can see in the upcoming demonstration, electricity demand and generation fluctuates on daily and weekly basis, which is not reflected in monthly data. Data held by transmission operators are not publicly available for every province and are not available in such a way that standardizes across all provinces. So the goal of this project is to make it easier for Canadians to access high-frequency electricity data, as well as providing more comprehensive and accurate picture of the electricity system through data sets, tools, and visualizations. And so these data sets, tools, and visualizations are to help researchers and policymakers. And some examples include improving and validating models, which is particular interest here, managing resources, and monitoring the impact of significant events such as COVID and recent severe weather. So I'm just going to exit these PowerPoint slides so I can show you the tools that we've developed. So one tool that we've developed that will be being published quite soon is what we call our downloader tool. And this is really aimed at people who just want to access the data. So as you can see here, you pick the province of interest, the energy variable, and the data range, and you can just download the data into a CSV file and use it as you would. Just below here is a panel that kind of demonstrates what the data looks like before you download it. The second tool that I would like to show you is what we call the dashboard. And this tool includes things like data definitions, visualizations, so very much targeted at a wider audience. And I'll just scroll down here and you can see, so for example, our landing page will show load data for every annual or hourly load data for every province in which that data is available. I know it's taking a little bit to load here, but that's because when you think about it, every 5 minutes of data over years is massive data sets. Also of interest, you can click here, and if there's a particular province of interest that you're interested in, you can choose the province of interest and then see what data is available. So for example, I've chosen Quebec, there's demand data and there's generation by type. You can play with the frequency and you can play with the duration of the data for your visualizations, but you can also just export the data and use it as you will. So as I have mentioned, this is all publicly scraped, are all scraped data from publicly available websites. That's where we are. We're very much still interested in obtaining a more complete data set, so obtaining data that may be not publicly available. And we're very much open to working with any kind of data providers who may be interested in working with us to make a more complete data set available. So that being said, I'd like to welcome Emily.
There we go. So thanks, Kristen. So I'm a senior analyst with the CCEI, and I'll just take a few moments to talk to you about a new tool, another new tool that's on the CCEI website, the .stat Data Explorer. So the Data Explorer uses statistical data and metadata exchange standards, or SDMX for short. Some of you may be familiar with that acronym. And it's an open source tool that's part of the .stat suite of SDMX tools. And these were developed in partnership with an international community of statistical and financial institutions that wanted to share data amongst themselves more easily. And so are collaborating on this initiative. And those would be organizations such as the International Monetary Fund, the OECD, the UN, and the World Bank. And the Data Explorer uses SDMX to ingest data sets and make them more accessible to users, including data from non-StatCan sources, because we have both StatCan and non-StatCan sources. And this is important because for the energy space, there is no single authoritative data source, so it's important to amalgamate those various data sources into one centralized location. And this supports the goal of this Canadian Centre for Energy Information to be a one-stop shop that makes data more accessible and usable for people like yourselves who are looking to find it. So in addition to downloading the data in CSV format, users can view data tables, choose preferred chart types, and access the data through APIs, which I've heard from some of you is of great interest, so that you can then feature it on your own visualizations and dashboards in real time. So yeah, I'll do another quick demonstration. So here we have the Data Explorer tool. You can see that you can search by keyword or by topic. You can choose a data source or like a topic of interest. So say natural gas, and then choose a particular data set. On the first view, you'll see metadata and source information. And then, whoops, I have to get underneath. And then you can preview the tables, see some of the data points that are available and the variables, and choose a particular chart type that might be of interest. And as well, having the download button right there, I think is of great interest for people because we do have a lot of this information on the CCI website, but this is really for our power users who just want to have access to the data. Having that button really up front and center, I think will be helpful. And then over here, I want to draw your attention to the API, where for your own website developers, that's what they'll be looking for in order to draw particular data sets or variables to feature on your own websites or visualizations. So, what else do I want to say here? So this is live on the website now, so I would encourage you to go check it out at your leisure. Send us your thoughts and comments because we're definitely looking to continue to improve it, and that's in collaboration again with the SDMX community. And while we're on the site, I will just take a moment to draw your attention to a couple other new things. So we recently published a page on coal, which those of you who are on our mailing list might have received an email about that, and an article that went out about coal today. And I think of particular interest to this group would be our page that's just very recently been released on energy modeling and projections, which has been in the works for a while. And it features links to the Canada Energy Regulator, the Energy Modeling Hub, and then we also have a visualization for Environment and Climate Change Canada greenhouse gas emissions projections. So yeah, I encourage you to check that out as well. I think that's about it, so thank you very much.
Thank you. I'm sure it's a great of interest for many modelers to find good data out there. So next we have Jessica Webster, an energy planning analyst with NRCan at Canada Energy Ottawa. With 18 years of experience, Jessica is also a valuable member of our data committee. So Jessica is joining us from remotely. So if we can put her on screen, be presenting her tools. Awesome.
Good afternoon. Are you able to hear me?
Are you there, Jessica?
Yes. Are you able to hear me?
Yes, now we can.
Okay, wonderful. Thanks very much, Edouard, and thanks so much to EMH for having me today. My name is Jessica Webster. I'm an energy planning analyst with Canada Energy Ottawa, and I'm excited to share with you about an initiative called Testbed 18 that NRCan conducted in collaboration with the Open Geospatial Consortium. Next slide, please. In this interoperability demonstration, we leveraged open data standards to combine buildings and energy data dynamically over the web to create energy maps of buildings. I'll set some context for you. So if you've ever heard of other standards organizations like IEC or ISO, just know that the OGC is one of those. It's a standards organization, and it is the leading standards organization that develops mapping standards. So it develops and maintains over 80 standards, and if you've accessed the weather on your phone or taken a plane trip in the last few days, you've interacted with OGC standards, perhaps without even knowing about it. They host annual interoperability demonstrations called testbeds, and that's one major way that they advance the research and demonstration on existing standards and understand where new standards need to be developed. So in 2022, NRCan responded to their call for sponsors for Testbed 18 and sponsored the Building Energy Data Interoperability theme. The money flowed from the GeoConnections division of NRCan, so would definitely like to acknowledge their support, and was supported by myself from Kemet Energy, but also a whole range of colleagues from across the department. We consulted broadly and got input right from the RFP process right through the end of the engineering report. This work contributes to the building of what's called Canada's spatial data infrastructure to enable the discovery, access, sharing, and use of geospatial information. I know APIs was mentioned in the last session, in the last presentation, so I'll just quickly point out that the OGC and their standards is moving towards an API-based approach. Next slide, please. So with regards to testbed 18, some of our goals included evaluating the interoperability requirements for existing energy and buildings data sets, demonstrating the use of existing standards, and understanding where future standards work would be required to build out an energy spatial data infrastructure. Our priority use cases were housing retrofit program planning. We also identified utility hosting capacity analysis in the initial RFP. Unfortunately, we didn't get any response through the RFP process to that particular use case, so we wound up focusing exclusively on housing retrofit program planning. But I would point out for present company electricity system modelers that idea of assessing building energy efficiency as a contribution to hosting capacity analysis is an idea for future research, including leveraging spatial data standards. All of this works towards contributing to an energy spatial data infrastructure towards our common objective of achieving net zero emissions targets. Next slide, please. The testbed pursued a really innovative contracting approach. So as mentioned, the funding flowed from NRCan to the Open Geospatial Consortium. The OGC issued an RFP, and they didn't just hire one company, they hired a retinue of domestic and international companies and universities to participate in the testbed. So this is a really innovative approach that builds redundancy into the architecture of the testbed to demonstrate the standards not once but twice to really prove that they work and also better understand, the limitations around the existing standards. Next slide, please. We had a number of great Canadian startups as well as Concordia University that participated from Canada. So we spent a lot of time at the outset discussing where we would conduct this demonstration, and we settled on the City of Montreal, and we organized the work in 3 tracks. So the first track was on an area called Nuns Island. So this was where the most extensive work was done on the testbed. So a 3D buildings model was constructed of Nuns Island using City GML, and then additional standards energy application domain extension was used to attribute the energy data to the buildings. Next slide, please. This slide illustrates the standards that were used. So the 3D building model was built using City GML. City JSON was another building standard that was also experimented with. The standards in the center pertain to the integration and processing of data. So these standards enable building energy simulation to be conducted dynamically in the cloud, drawing from data sets at different locations. That specifically is the OGC API processes standard that enables that. I'll also point out that OGC ST API, what does that stand for? It stands for Sensor Things API, and so the OGC does have a standard for sensor data, which might be of interest to some of you. All of these standards serve to pull the data, integrate it together, map it, process it, and then the data can be pulled through the APIs by the various clients for visualization. Next slide, please. The second track looked more broadly at the whole City of Montreal, and a whole buildings data set was created in City GML for the entire geospatial area of Montreal. This track also built out a HOT 2000 reduced file that was served via an API. In the end, that file wasn't used, and I'll explain a bit at the end about why that happened. But track 2 was very successful in building out a 3D standards-based buildings data set of all of Montreal. Montreal. It leveraged data from the City of Montreal as well as Natural Resources Canada. And Concordia University is continuing to use this data set for various projects that they're working on, including with the Quebec Ministry of Environment, the City of Montreal, and the Desjardins Bank. So it really illustrates the value of a standards-based buildings data set, because it means that that data set can be used and reused for multiple initiatives. Next slide, please. Track 3 is where things got visual. So I mentioned that there was numerous companies and universities engaged in the testbed, and many of them acted as clients, so consuming the data and then visualizing it using different mapping platforms. So on the left, we have a visualization from Interactive Instruments, and on the right, one from Steinbeis and Fraunhofer. Both of these are illustrating monthly heating demand visualization on a building scale. So yesterday it was mentioned that the grid might need more flexibility, and so mapping building energy demand could be one way that some further insights are gained into building energy efficiency to support grid flexibility. Next slide, please. In addition to some basic online maps, there was also a really innovative edge of this project was an augmented reality application that was developed by a company named Ethar, based in the US. They serve the architecture, engineering, construction industries a lot with augmented reality applications. So this is the first time they did a building energy map, but the prototype does prove that it can be done. They were leveraging some standards from the gaming industry, so that was really interesting to understand that some of those standards were also brought to bear in this project. Next slide, please. So some of the recommendations, I've pulled out some of the recommendations centering on data for today. There were many, many recommendations in the report, but I think the ones pertaining to data might be of most interest. And of course, the report, the engineering report from Testbed 18 was focused on buildings and energy data sets, but I think some of these recommendations may resonate with folks no matter the data set that you're pursuing. So some of the recommendations from the Testbed 18 engineering report included that buildings and energy data sets should be fair, findable, accessible, interoperable, and reusable, while ensuring privacy and commercial confidentiality. With regards to interoperability, in the testbed, it was discovered that the proponents spent a lot of time cleaning the building's data at the outset, and they had to do that because there was different terminology in the different buildings data sets they were pulling together. So another recommendation is, for federal leadership on semantic interoperability to align the terminology across buildings and energy data sets to really enable them to talk to each other. Another recommendation was around documentation, and so we weren't able to use the HOT 2000 files in the end because some of the software developers were missing key information about the data. They were missing some pieces of documentation that enabled them to leverage that data. So there's a key recommendation there, that in this case applies to NRCan modeled energy data sets, but certainly can refer to other data sets as well. Good documentation helps ensure, good reuse, highest and best reuse. With regards to standards, I think we can see the value of standards-based buildings data sets, but the adoption of standards by data custodians really does require leadership from government as well as within organizations that are maintaining and collecting data. And last but not least, the report makes a recommendation concerning open buildings data. An open and fully attributed buildings data set at the building and parcel scale would save modelers time and effort. And based on some of the models that we've seen over yesterday and today, I think if Canada had such a buildings data set available, it would really support folks to sort of drive down the spatial scale of their modeling and understand, grid impacts at lower geographies. Next slide, please. Another key recommendation was around sharing of this energy spatial data infrastructure concept. And so I'm pleased to share this diagram with you. This is the notional energy spatial data infrastructure. It's really a sort of conceptual model of how an energy infrastructure could be structured, going from the data through computing, services, and applications. And I think this diagram, as well as other diagrams like it, can help all of us in EMH sort of come to common understandings of what we're collectively working on, and also where we fit both individually and with our initiatives and organizations, where we fit in this hierarchy of things. I'd invite you to check out the study that diagram is contained in. Next slide, please. Some of the key outputs that I'd also invite you to check out, there are some videos up on YouTube. So if you Google Testbed 18 Building Energy, you can see some videos online. We also have our final engineering report. I'd like to give a quick shout out to a couple international initiatives that we learned about in the course of Testbed 18. I really encourage everyone to Google Project Plateau Japan. So within about the last 3 or 4 years, the Japanese government has led all municipalities in Japan to build out an online digital twin of Japan based on standards. And they're reusing it for multiple use cases. They're into the dozens of use cases that they're applying this digital twin to. So I think that really is a testament to the value of standards and this idea of being efficient and effective in tackling some of our collective challenges. So they're addressing urban planning challenges as well as energy and climate action. The UK Ordnance Survey also has a really great data hub that it's also stood up on a standards basis. Next slide, please. Last but not least, the next study that will be conducted with the OGC is being sponsored by the Department of National Defense. It's going to be called the Integrated Digital Built Environment Concept Development Study. So it's really focusing on building information modeling and GIS interoperability. They're looking to leverage OGC standards as well as other standards organizations such as from Building Smart and ISO. D&D will also be initiating a national joint committee on the digitization of Canada's built environment. If you'd like more information on this particular study, or if you'd like more information on OGC, I'd invite you to get in contact with my colleague Ryan Hola. His email is at the bottom of the screen there. And certainly I'd be happy to follow up by email or LinkedIn afterwards should anyone have any questions on Testbed 18. Thank you so much.
Thank you, Jessica, for accepting to do the presentation. And at last, but certainly not least, I'm proud to introduce our very own Madeleine McPherson. You know Madeleine, our co-scientific director at EMH, assistant professor at UVic, and she leads the CICET group. And today, Madeleine will present and officially launch, I might say, the much anticipated M3 modeling platform that some of you already saw in the other room. So Madeleine, the floor is yours.
Great. Thanks, Adair. There we go. Okay, great. Thanks. Hopefully the slides will come up in a sec. Yeah. Oh, okay. Okay, so yeah, thanks, Edward. So today I'm really pleased to announce the launch, finally, of our M3 modeling platform. Many of you in the room have been hearing about this for years now, so I apologize in advance for the broken record. But finally it's released. So today I'm going to go through what the M3 modeling platform is through a couple of demonstrations, some of the work that we've been doing over the last few months with the platform, and some of our plans going forward for the next year or so, and then finally how you can get involved. So the modeling platform is there we go. I think, Canada's first open source integrated energy data and modeling and visualization platform. We've released it publicly now on GitLab, really for the whole community to use. And this is really a platform that we've designed and developed for exactly this community and the number of different users who are here in the room. So it's up and it's open, and we're really hoping at this point that we can start to use it with all of you, and also start to get some contributions back from the community and to collaborate in different ways. The developers have done a just incredible job of setting it up in a way that's very easy to download and use. And we've spent a huge amount of time on documentation. And so hopefully it's easy to use. That's really one of our main goals, one of our main priorities is a low barrier to entry. What is the modeling platform? I think most of you, some of you, again, this is probably the umpteenth million time you've heard it, but this is a slightly different slide now, so maybe a little bit different. It's an open source integrated tool that really combines energy systems data with models and with visualization tools. So we've got a soft coupling between these three sort of different pillars of the platform, data, visualizations, models, that are integrated together on the spine toolbox, which is something that enables the integration of these three different pillars. And you can see there the repos to download each of those components individually. So if you're just interested in the data, or if you're just interested in the models, or you're just interested in the visualizations, or you can download the platform as a whole, which encompasses all of those pieces together. So what are some of the features? Well, this is, as I said, we've really tried to design this with use cases or users in mind. So I've listed 4 there. Maybe you're somebody who's just interested in data. You've got your own models and your own visualizations, but you struggle to find data. Then maybe you're just interested in accessing coders to enable your own workflows or your own analyses. Maybe you have your own data and your own models, but you would like to visualize them in some kind of way. We've got a database now with a standardized format that if you get your data into that format, you can then use the visualization tool that I'll demo in a sec here to facilitate some analysis, maybe comparisons with other model runs that have been done that are also up on the database, or other people that you're collaborating with who have their own data. So that ability to kind of compare, analyze, engage with stakeholders. Or maybe you actually want to run the models yourselves, do your own kind of analysis with the modeling tools. So right now we've got silver and copper production cost and capacity expansion model that is currently on the platform and supported, with more models to come in the new year. So those are sort of the different use cases that we have in mind, and really at the end of the day, what I really want to emphasize is that this is hopefully what we really want is for this to be a community tool, something that the community comes together to use, contribute to, give us feedback on what's working, what's not working, and that as a community we can sort of raise the bar all together, that we're not going around all clutching our own data sets, not being able to compare results with one another because we're using different units or different color schemes on our visualizations. So that's really the point, is that this is a community tool. And a lot of the stuff that we've heard here today for the last few years about what that means, how to actually do that, we've really tried to strive for. So transparency, reproducibility, usability, and this idea of integration. So if you're someone who's got a whole energy economy model and you want to dive deeper into the power system, instead of developing your own power system model, can you work with some other people in the room or with EMH to develop those linkages? So just a little bit of history. It sort of dawned on me that this actually has been 10 years in the making, different pieces of this platform, starting with some initial model development, and also over 40 contributors. I sort of went through and added up the number of students, software developers, collaborators who've contributed different bits and pieces of this, and I got to more than 40 people. So, big development on silver that started in 2013, and then copper, moving into coders, which has been under development for 4 or 5 years, had tons of contributions. The idea visualization platform more recently, and now today here we are with sort of trying to release it all as this very integrated platform. So we'll launch into a couple of demos, and I'll just get Maddie and Jake and Nathan and Devin to stand up. If you haven't had a chance to go into that room, these four wonderful people have actual demos of the platform up and running on their machines, sort of a tech tango idea. So this is you basically see this, but you can ask more detailed questions and get them to actually explain in more detail in a live demo what's going on. But what you're looking at here is the full spine workflow. So on the left, starting with a call to coders collecting the data, moving through to creating a database for the specific model that you're working with. So here I'm showing three parallel workflows: silver on its own, copper on its own, or copper and then populating itself to silver through a linking tool. And then IDEA being launched, which is our visualization platform, on the very right-hand side. So the idea with this is, if you're not a model developer, but you're interested in inserting your own data, for example, you can add your own database into this workflow, override or complement the coder's workflow, and then continue on with the rest of the workflow. Or you could insert your own model into this workflow, develop linkages with coders and the visualization platform, and then use your own model in here, or any combination of the above. So it's, yeah, again, with that sort of user perspective in mind, different ways of interacting with the platform. So the visualization platform can either be run through your results, maybe that you have on your own local machine, that you don't want stored in an open database. So you could visualize those results by going through this sort of process of finding them on your own local machine. And then this is, again, just a demo of that platform, flipping through different kinds of results like capacity expansion or transmission expansion, costs, greenhouse gas emissions. The other alternative is that you access the database containing a bunch of different results. So the results that Jake showed earlier today, for example, on the CER, that's up on this database. So if you wanted to go and play around with those, with that data, you could do that, or send us your data for results that you've done. We can put it into the database, and then we can start to do very cool comparisons and analyses across different model platforms, different analyses from different groups. So we've already been using the M3 modeling platform in a number of different ways over the last few months. So with stakeholders assessing the impact of the CER, you saw some of that work on an earlier panel, as well with other modelers doing some comparisons, model comparison work. It's obviously something that supports our own research. PhD and master's students completing their own research will use various and contribute various bits and pieces to the platform and publish that usually. And we've actually also used it, I've used it in the classroom with students who are not necessarily modelers, but who want to be able to analyze the outputs of models for term projects, for example, so also as an education tool. So looking forward, we've got a few exciting plans for the coming year or so. We've got a new project that we've just started called Open Insights, in which we'll be collaborating with a team at the University of Oxford to integrate 4 new models onto the platform that we'll be looking at labor, macroeconomics, technology costs, and energy companies. As well as integrating with the SIMS model. You saw some of that work from Aaron and Brad earlier today, and integrating the message model on. So integrating some more models onto the platform to kind of build out the suite of analyses that we can do, and then developing linkages between various bits and pieces of those models. We'll also be doing a multi-model comparison workshop in the summer. I think a few of you are implicated in that. And so this is really, the idea here is really to try to do some of the model comparison work that we saw a little bit of with the CER panel, but going a little bit deeper in that, looking at real numbers. And then we'll continue, obviously, beyond 2024 into the fall, really trying to improve the user experience, continuing to build out coders, adding more visualizations to the platform. And this is really where your feedback is really helpful to continue this development. So how can you get involved? If you're interested in using the modeling platform, you can find the repository there. You can download, as I said, the whole repository is sort of one big repository that has everything in it, coders, well, not coders, but links to coders, Silver, Copper, IDEA. You can contribute to the platform, so we've got a GitLab issues board, so this is kind of our to-do list of what we're planning on doing, so you can see what our plans are moving forward and different sort of how we've prioritized different things. So let us know if something's missing from that list or if you feel like the priority is off. You can access that GitLab issues board. If you're interested in visualizing your own results on the IDEA platform, definitely let us know. There's an email there for you to let us know. Or adding your model to the modeling platform, so developing those linkages with the data set and or the visualizations. And last but not least, please check out the demos in the next room there if you haven't had the chance to do that already. I'll wrap up there. Thank you.